So Nand to Tetris part 1 hardware, and here we have logic for Nand, which is 0 0 is equal to 1, 0 1 is equal to 1, and 1 and 0 is equal to 1, and 1 and 1 is equal to 0. This only 1 and 1 is 0. So you will ask why this 1. You have to understand before this, and let's understand while doing this. And you have to understand the AND logic gate. This is AND logic gate, and this is NAND logic gate. So what's the AND logic gate? So something like this: true. Before we understand this, truth table. Okay, truth, false, and here we write truth, false, another one false, and what the output will be? True will be always true. No, this is the truth table, right? Okay, true. So here let's start doing for the AND operator, this one. Okay, let's do the for AND operator. So let's start. Let's write the truth table again here for the AND table. Let me just copy it and paste, and once we done, now let's look for the AND. True is true, and false, true or false. In the AND, what is the thing in AND? If both are true, then only true. If one false, then all the cases will be false. So all the remaining of this will be false. Why? Because in order to get true value from AND logic gate, you have to have both value 1 and 2, both value 1 must be true. This also true and this also true. That's why here it's false, because we have this false, and here all are false, that's why false. This concept will better get understanding if you do this. If you see this now, what this then? What is the NAND then? NAND is something opposite of this AND. Is like opposite of AND is NAND. What we are doing? So here 0 0 becomes 1, and 0 1 becomes 1, 1 0 becomes 1, and 1 1 becomes 0. Okay, here you can see 1 1 become 0. Here in the AND you can see they both are different, right? Here the false became true, right, and others get false. But in NAND logic, okay, let's simplify it. Okay, here's in AND, what will happen? True and true will become true, and if a value is true but false, then it will be false. And here I just made a mistake, my bad. Here it would be true, that's why truth. So if one value is false, another one is truth, then this is also become false. False become false, that's by default, false truth false only will be true when true and true is there, others false. But what happen if we do opposite of this? This is the same thing when with the opposite and. So 0 0 becomes 1, 0 1 becomes 1, and 1s and 0 become 1, and 1 and becomes 0. So here this 0 and 1 is called bits, and it looks like this a lot, but it's just a 1s and 0, so there is no need to get fear of this. And let's talk about some programming or Java. You don't need to learn this right now, just I'm telling you, okay, this is a Python code or a Java code, and it's look like it's a code of set of instruction code which will do something and give you some output, right? And this code gives you 1 2 3 output. Okay, then the question comes like this: when I run this code, it shows me output like this, then how like it's happen? So it's happen like we have a program file in our computer, okay, and it get translated into this bits 0 1 0 binary code into 1 or 0 like this. It got this program lines got translated into this thing 0 1, then this 0 1 code execute runs in hardware, goes to execute, then goes to hardware, then hardware process it and shows you in the monitor your screen and output. That's what it happens. Now we are building the NAND thing, NAND thing. So here's the abstract concept, just above level we will see it. So program we are writing any program, any high level program, any program language you choose, C, Python, Java, okay, and operating system this is, and we choose any language or okay. Then once we write, we send them to in the terminal, and the code gets compiled into 0 1 something. The code will get compiled, just we saw like how it happens, and then it goes to VM machine. Okay, this assembler is important. It converts the machine language into hardware language, okay, and then it goes to computer, then it goes to like computer, and what inside the computer like ALU or RAM, like then from here computer to here chip, which is elementary logic gates, which is the gate thing which we are doing and interested. So finally we arrive at this NAND, and we are going to use this. So that's a concept for the NAND Tetris, or part 1 for hardware, and it's is to be really true with you, need some understanding, or you just have to be patient for this to get understand. Now I know it's very hard for you to get it. If there is any points you don't get it, or even I also not have that much what I can say to clear you, my words are very bad. So we will just keep building small steps and progress it. So that's all for this video.